Hello everyone. Welcome back to Dr. Lou's VCE Physics channel. Today, let's learn together about the 2020 VCE Physics. We will focus on questions related to Newtonian mechanics. My explanation may need to be revised. If any teachers, parents, or classmates find errors, please feel free to provide your guidance. Both blocks move together, so they have the same acceleration. Furthermore, the 5 kg block has a half mass of 10 kg block. Thus, the magnitude of the net force on the 5 kg block is half the magnitude of the net force on the 10 kg block. However, the forces that both blocks push each other are action-reaction forces. This pair of forces is not the net force. The value of force and distance are substituted into the work equation and the answer is option A. All the spring potential energy is converted into the kinetic energy. We establish the equation between these two energy types and solve the ball's initial speed. Ask the speed of the ball but not the vertical speed. During the ball falling, the energy is conserved and the total final energy is equal to the initial energy. If we set the group as zero level, the final energy is only composed of kinetic energy. Initial energy is the sum of kinetic energy and gravitational potential energy. After establishing the equation, we substitute the value of height, initial speed, and gravitational acceleration, and then calculate the final speed. Also, we can use motion equations to calculate the speed of the ball when it touches the floor. This motion is decomposed into two motions, the vertical, x, and horizontal, y. The vertical motion is free-falling, so we use the free-falling equation to calculate the vertical speed. The horizontal motion is constant velocity, so the final horizontal speed is equal to the initial. Finally, we use the Pythagorean to calculate the sum speed when the ball touches the ground. During a collision, total momentum is conserved. We set the right direction as positive, so the initial velocity of the 1,200 kg car is positive, and the final velocity of the 2,200 kg car is positive. The final velocity of 1,200 kg is negative, so this car moves in the left direction. Please note that both the direction and magnitude are asked. Calculate the initial and final kinetic energy of the system, respectively. Comparing them, we find that the final kinetic energy is less than the initial. Thus, this collision is inelastic. Please focus on the 2,200 kg van. The initial velocity is 0 and the final velocity is positive 6.5. Using the impulse momentum equation, we calculate the average force on the van. This value is positive, so the force directs right. The magnitude and direction of the force on the car by the van are asked. Using the impulse momentum equation, we calculate the average force on the van. This value is negative, so the force directs left. However, a new calculation is not necessary. It is full marks that students apply Newton's third law and indicate that the force has the same magnitude but in opposite directions. In Newtonian mechanics, 2 multiple-choice questions are worth 2 marks, and 2 short-answer questions are worth 17 marks. The overall score for this section is 19 marks. With a total possible score of 130 points, the percentage for this section is 14.6% of the total score.
If you need my help, please add me on WeChat or WhatsApp and send me an email. Thanks for your attention. Please note Dr. Lou's VCE Physics channel, Dr. Lou's VCE Chemistry channel, and Dr. Lou's VCE Biology channel.